A warm good morning, guys. Today we are gonna solve a Leetcode hard problem, that is binary tree maximum path sum. I have already solved this question, so I'll try to implement it within the time frame, and we'll try to make you understand how we'll go through the solution. So first of all, the question is very clear to us that we have to find the maximum path for the tree, right? So let's take this example. As you can see that we have to add these elements, and we'll get the maximum path as 6. Okay, let's take this example. So let's say it is minus 10, what is it, 29, right? So this is 20, this is 9, 15, 7, right? Yeah. So this would be 15, and this would be 7, right? So what does that mean? How to find the maximum path sum? If we add, first of all, let's say the value for this would be none, right? This would be none, this would be none, and this would be none again. So basically, whatever, if the root is equal to none, we are getting the none. Just return the value of 0, right? So from here, you can see that the value that goes up is 0 in the 7 element, right? So what we have to do now? So first of all, if we are encountering the value of 7, we have to put a current sum. There should be a variable of current sum. My handwriting is somewhat worse. I'm writing from mouse. That's why. But the current sum, we have to take it as the 0 because this value that it is coming from is 0. With you, let's say there are some elements like negative elements, right? This, let's say this is only the negative element we have, the root. So whatever it is having, it would be coming from 0 because the value from this is none, right? Left side and right side would be none. So the value it is getting is would be 0. So basically we would add this minus 4 with 0, right? And we'll see that is it the last sum, like maximum path would be set, right? Maximum path would be set to negative infinity. So we'll take this value and correspond to that, we'll check with negative infinity and negative 4. Which one is the bigger one? Like which one is the bigger one? As minus 4 is the bigger one, we have to return that. That is basically the sum ideology. Let's try to implement it. You can just understand how we'll go through the sum. We have to have a maximum path that, let's say, it would be negative infinity. So this is an and we have to make another function as a DFS, and we, let's say, the root variable that we are passing, I'll pass it into this value. You'll see why we are passing this, because it is a recursive function. So this function should be called again and again. uh, and non-local path, why we are using this? Because as you can see, the max path is beyond the definition of the recursive function of DFS. So that's why we are using the max path, so that I can get it into the variable. So max path would be declared inside this, as I am declaring it globally, but for privately I have to include this. So that max path is in bound of DFS. That is what it is, right? So what we declared, as I said, that whatever the last element, its root touches to none, right? What you have to return? To 0, right? That is what is clear. As I said here that you have to return 0, right? As it is none, let's say this is the value, this is the root value, this is the root value, but we don't have anything here. It is null, right? It is null. So what you have to return? You have to return 0. That's what it. So next thing would be you have to create a, sorry, comment the left side, okay? Left side, and you have to create a variable of, let's right. What does left side do? You have to do maximum DFS. I'll make you understand what this it means. But DFS of whatever the node left, comma, max DFS. What, so what does this line? That's the left side. So left side means, like, let's say this is okay. All of And okay, okay, this is 4, this is 10, this is 20. What does that mean? Left side means this value, this value. If we are on this, the left side would be this value and this value, right? So from here, the left side would be 10 and here it would be 20, right? It is right side value, but it is left side value. It is left side, right side value. That is what we wanted up till here. That is what we want here. The maximum of this or 0, right? As in -4, -100, and let's say this would be -200. Why we are taking 0? In this case, you can see that we are taking 0 as a variable because -4 is the maximum path we want. So as we take here 0 and add it up to it, it would be -4 only. So the maximum path would be -4. That is what we want to return. You cannot just add -100 as a maximum path because then it would be -104. That is false, right? That's why we are returning 0 if it is in negative case. Okay, that we got understood. Okay, we got left side, also we got right side. Now what we have to do? As we are getting from here left side, we are getting right side. Then what is the current sum? Right? Current sum. The current sum will be whatever is the left side and plus right side plus whatever the node the value. As it means like 4 plus 10 plus 20. This is the current sum of this node. That is what we are denoting. Current sum will be this sum. We got that. So what is the maximum path you're finding? Right? What would the maximum path? Maximum path would be maximum of current sum and maximum is having. That is what that's it. As whatever is this value and the current sum we are having. That would be the maximum path. Okay, got it. What we have to return? We just have to return the value plus maximum of left side comma right. What does this mean? Mean that let's say node value is uh, let's say node value is 4 in this case, and here it is 100, and here it is 200. The maximum path, like this path, what we are returning from here, it will be 204 because this is 200. That is what it is coming up, right? This is coming, but as we are taking the maximum 200, 200 plus 4 would be 204. That that is the value we are returning to another nodes that are connected, right? That is what we are returning from here. It would be 204. That is returned from here. That is what it basically. So yeah, that would be it. And we just have to, after returning this, then we have to call the DFS, right? With the root value, and then return the value of maximum path. This, that would be it. So max path. Okay, it's max path some variable. What is that? Root. Okay, it's like sorry, node. My fault. Again, it's what equal to that is that, and I think it would be done. Pretty much done. Yeah, that's it. Thank you for listening. I hope that you all understood this question. Thank you very much.